Hi students, good morning. In the last class, good morning. In the last class, we have discussed the chord of contact and polar concepts. The equation of the chord of contact and pole and polar of a point with respect to a circle we have discussed in the previous class. We are continue the another concepts of the pole and polar in this session. Okay. See the theorem. The equation of the polar of the point p of x1 y1 with respect to the circle s is equal to 0 is s1 is equal to 0. This is the theorem. We have to find the polar of a point p of x1 y1 with respect to the circle s is equal to 0. That equation is s1 is equal to 0. Now we are proving this theorem. So see the proof here. Let capital A, capital B be the any chord drawn through the point P of x1 y1, and let the tangents at capital A and capital B meet at the point R of alpha comma beta. Look at the diagram. This is the circle. This is the circle. Now we have to find the polar of P of x1 y1 with respect to the circle. Suppose the given point is P is the x1 y1, B the exterior of the circle. What is the polar? What is the definition of the polar? Draw the secant through capital P to the circle. This is the secant through capital through the point P of x1 y1. Now this secant meets the circle at capital A and capital B. Now we are writing the tangents at capital A and capital B. Now we are writing the tangents at capital A and capital B. Now the point of intersection of these tangents locus is the polar. Now we are taken, that is the point of intersection R is alpha comma beta. Now this is the diagram. Now what is the polar equation of the point P of x1 y1 with respect to the circle? So what is the definition of the polar? Draw a secant through capital P to the circle. They meet at capital A and capital B. Now we are writing the tangents at A and B. The tangents intersecting point locus is the polar. Now we have to show that the polar of P with respect to the circle is the locus of R. That is, we are taken R is the point alpha comma beta. Now we are finding the locus of R. That is to show that that locus is S1 is equal to 0. Okay. So here AB is the chord of contact of R of alpha comma beta. Here the tangents through capital R to the circle, they meet at capital A and capital B. These are the tangents. So the meeting points of the tangents joining the line is the chord of contact of R of alpha comma beta. Now we are writing the AB is the chord of contact of R of alpha comma beta. So in this proof, we are writing here AB is the chord of contact of R of alpha comma beta. Now we are writing the equation of AB. Now we are writing the equation of AB. The equation of AB is the chord of contact of R of alpha comma beta. What is chord of contact? S1 is equal to 0. The equation of the AB is the chord of contact of R of alpha comma beta with respect to the circle. With respect to the circle, S is equal to 0. Is that is equation, that is S1 is equal to 0. Now we are writing for this alpha comma beta, we are writing the S1 is equal to 0. That is the equation x alpha plus y beta plus g into x plus alpha plus f into y plus beta plus c is equal to 0. Say this is equation 1. This is the chord AB equation. This equation 1 represents the equation of the chord. This chord is passing through the point P of x1, y1. Now, which passes P of x1, y1. Which passes P of x1, comma, y1. So, now we have to substitute this x1, y1 in this equation. Now, substitute P of x1, y1 in equation 1. Then we are getting here in the place of x1, x is x1, x1 alpha plus y1 beta plus g into x1 plus alpha plus f into y1 plus beta plus c is equal to 0. This is same equation 2. Now this chord equation AB, the chord AB is passing through the point x1, y1. So we have to substitute this point x1, y1 in equation 1. In the place of x is x1, in the place of y is y1, we are getting this equation. Now what we want to here, the equation of the locus of R of alpha comma beta. That is the polar of P with respect to the circle. This is the polar. This is the polar equation. Okay, now we are writing the locus of the point R. Therefore, the locus of R alpha comma beta is, now we are writing the locus of the point R, that is alpha comma beta. That is in the place of alpha is x, in the place of beta is y. We are getting the locus of this point R. So now we are writing the locus of R is x, in the place of alpha is x, in the place of beta is y. Now we are writing in the place of alpha is x, x1, in place of b is y, beta is y, y1 plus g into x plus x1. Now we are writing here beta is y, y plus y1 plus c is equal to 0. This is the locus of the point R of the point alpha comma beta. This is the locus of the R. R is here the point of intersection of the tangents drawn at capital A comma capital B. These are the meeting points of the secant through the point P of x1, y1 to the circle. So this is the locus of R. This locus is the polar of the point P of x1, y1 with respect to the circle by the definition. So what is this equation represents the polar of P of x1, y1, which represents which is the polar of P of x1, y1 with respect to s is equal to 0. That is the equation S1 is equal to 0. This is the equation representing xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is the notation S1 is equal to 0. This is the equation of the polar of P of x1, y1 with respect to the circle. This is the theorem for finding the polar of the point P of x1, y1 with respect to the circle s is equal to 0. That is the polar equation is S1 is equal to 0. Okay. Next, the theorem. The pole of the line Lx plus My plus n is equal to 0, where n is not equal to 0. With respect to the circle x square plus y square is equal to a square is the formula P is equal to minus a square L by n minus a square m by n. This is the formula for finding the pole of the line Lx plus My plus n is equal to 0 with respect to the circle x square plus y square is equal to a square. So this is the theorem. See the proof. Look at this diagram. This is our circle. Now we have to find the pole of the line. Suppose this is the line Lx plus My plus n is equal to 0. This is the given line. Now we have to find the pole. P of we are taken x1, y1 be the pole. Now these are the coordinates of the pole x1, y1. We have to prove that x1 is minus a square L by n and y1 is minus a square m by n. Now we have to find these coordinates of the pole of the line polar. So this is the polar Lx plus My plus n is equal to 0. Now we have to find the pole of this line with respect to the circle. Okay, this is our theorem. See the proof. Here given circle is the circle x square plus y square is equal to a square. So this is the equation 1. This is the given circle equation x square plus y square is equal to a square. Now we are writing the pole of the line with respect to this circle, and the given line is Lx plus My plus n is equal to 0. These are the given. This is the given circle and given straight line Lx plus My plus n is equal to 0. Now we have to find the pole of the line equation 2 with respect to the circle equation 1. Now let us assume that that pole is x1, y1. Now we are assume that let P of x1, y1 be the pole of equation 2 with respect to the circle equation 1. Now we are assuming that the pole of the line equation 2 with respect to the circle is equation 1. Okay. Now P of x1, y1 is the pole of the line, then the equation 2 is the polar of the point x1, y1. If P of x1, y1 is the pole of the line with respect to the circle, then this line is the polar of this point with respect to the circle, and P is the pole of the line and line is the polar of the point. Okay, now we are writing the actual polar equation of the point P of x1, y1. What is the polar equation? We are proving previous theorem, S1 is equal to 0. Okay, now we are to write the polar equation of P of x1, y1 with respect to the circle. Now we are assuming that P of x1, y1 is the pole of the line equation 2, then equation 2 is the polar of P of x1, y1. Here we are assuming that P of x1, y1 is the pole of the line equation 2, then the line is the polar of the point P of x1, y1. Therefore, here we are writing the equation 2 is the polar of the point P of x1, y1 with respect to the circle equation 1. Okay. So, equation 2 is the polar of P of x1, y1 with respect to the circle. Now we are writing the polar of P of x1, y1 with respect to the circle by using the formula S1 is equal to 0. Now we are writing the equation of the polar of P of x1, y1 with respect to the circle equation 1 is, what is the polar equation? S1 is equal to 0. What is here, what is S1? S1 is xx1 plus yy1 minus a square is equal to 0. For this circle, we are writing the polar of P of x1, y1. Okay, that is S1 is equal to 0. What is S1? Xx1 plus yy1 minus a square is equal to 0. This is same equation 3. Here, equation 2 is the polar of P with respect to the equation of the circle equation 1. Equation 3 is also polar of P with respect to the circle equation 1. These two equations 2 and 3 represents the same line. Since these two are the polars of P of x1 y1 with respect to the circle. Since here equation 2 and 3 are the same. These two lines are represents the same line, then the coefficient ratios are equal. Therefore, we are equating the coefficient ratios here. The x coefficient is here x1, here x coefficient is here L, x1 by L is equal to, here y coefficient is y1, in this y coefficient is m, that is equal to minus a square by, what is here constant n. From this equalities, now we are getting x1 y1. We are equating these two. We are getting x1 by L is equal to minus a square L by n. From that, x1 is equal to minus a square L by n. And also equating last two terms, we are getting y1 by m is equal to minus a square by n. From that, y1 is equal to minus a square m by n. Okay, now we are getting x1 and y1 values. This is x1 and this is y1. These are the coordinates of the point P of x1, y1. What is x1 here? Minus a square L by n. And what is y1? Minus a square m by n. These are the coordinates of the point P. What is here point P? P is the, we are assuming that P of x1, y1 be the pole of the line equation 2 with respect to the circle. Okay, therefore, the pole of the line, therefore, the pole of the given line with respect to the circle is P is equal to minus a square L by n, comma, minus a square m by n. This is the formula for finding the pole of a line Lx plus my plus n is equal to 0 with respect to the circle x square plus y square is equal to a square. Here circle is a simple circle. What is the simple circle here? The center is 0, 0 and radius is a. For this circle, we have to find the pole of the line Lx plus ma plus n is equal to 0 is the formula P is equal to minus a square L by n, comma, minus a square m by n. This is the formula for finding the pole of the line with respect to the circle. Okay, this is the formula. It is very important and it is also used in objective problems. Okay, next see the note here. The pole of the line Lx plus ma plus n is equal to 0 with respect to the circle x square plus y square plus 2gx plus 2fy plus c is equal to 0 is P is equal to the formula minus g plus L r square by Lg plus mf minus n minus f plus mr square by Lg plus mf plus n is equal to 0. This is the finding the pole of the line with respect to the general equation of the circle. In previous theorem, we have to find the pole of the line Lx plus my plus n is equal to 0 with respect to the circle x square plus y square is equal to a square. Here we have to find the pole of the line Lx plus ma plus n is equal to 0 with respect to the general equation of the circle. So we are to proving in previous theorem as like here the pole is the formula minus G plus LR square by LG plus MF minus N minus F plus MR square by LG plus MF plus N. This is the formula for finding the pole of the line with respect to the general circle, where R is the radius and minus G minus F is the center of the given circle. Now we have to finding these parameters and substitute in this formula. We are getting the pole of the line Lx plus Ma plus n is equal to 0 with respect to the general equation of the circle. Okay, that is the first note. Next, see the second note here. The polar of P of x1 y1 with respect to s is equal to 0 passes through Q of x2 y2. If and only if the polar of Q passes through the point P. These are the two statements, vice versa. So first, we have to take in the circle is now just see the solution for this second note. Okay, see the solution. So let we have taken S is equal to the general circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now we are writing the polar of P of x1 y1 with respect to the circle passes through the point Q is x2 y2. Now first we have to take the first statement. Let now we are writing the polar of P of x1 y1, polar of P of x1 y1 with respect to s is equal to 0 is, what is the polar equation? S1 is equal to 0. What is the S1 for the point P is x1 y1, x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. This is the equation of the polar of P of x1 y1 with respect to the circle s is equal to 0. Now this polar passes through the point Q of x2 y2. Here the point Q x2 y2 passes the polar of the point P of x1 y1 with respect to the circle. Now the point Q, the Q is x2 y2 lies on this equation 1. Now I have to substitute here Q is x2 y2 in this equation. We are getting x1 x2 in the place of x is x2, in the place of y is y2. We are getting x1 x2 y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c is equal to 0. What is the notation of this equation? x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c is equal to 0. That is, we are using the notation S12 is equal to 0. That is same equation. That is equation 2. Okay, that is equation 2. Okay. Now we are writing the polar of P of x1 y1 with respect to the circle, that is S1 is equal to 0. That polar passing through the point Q is x2 y2. That is the first statement. The Q point passes this polar equation. Now we have to substitute this Q is x2 y2 in this equation. We are getting S12 is equal to 0. Okay, next we are writing the polar of Q of x2 y2 with respect to s is equal to 0. So we are taken converse part. What is converse part? The polar of Q passes through the point P. Okay, first we are writing the polar of Q of x2 y2 with respect to the circle. What is the polar of Q? Q is x2 y2. So now we are writing the polar equation of Q of x2 y2 with respect to the circle is S2 is equal to 0. Here the point is x2 y2. So now we are writing the polar is S2 is equal to 0. What is S2? X2 plus y2 plus g into x plus x2 plus f into y plus y2 plus c is equal to 0. Okay, now this polar passing through the now we are writing here the polar of p of x1 y1 with respect to the circle s is equal to 0 is s1 is equal to 0. Now this is the polar equation of p of x1 y1 with respect to the circle. This polar passing through the point q of x2 y2. Okay, so this q is lies on this equation. Now we have to substitute, then we are getting s12 is equal to 0. The converse part is the polar of q of x2 y2 with respect to the circle s is equal to 0 is s2 is equal to 0. What is s2? X2 plus y2 plus g into x plus x2 plus f into y plus y2 plus c is equal to 0. Now this polar passing through the point q. Here the statement is the polar of q passes through the point q. So q p point here x1 y1 lies on this equation. Okay, now we have to substitute x1 y1 in this equation. We are getting x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c is equal to 0. That is the equation. This equation representing the s12 is equal to 0. Here this is the we are getting in the first statement the polar of p of x1 y1 with respect to the circle s is equal to 0 passes through the point q of x2 y2. Then we are getting s12 is equal to 0. In the converse part also we are getting s12 is equal to 0. That is the polar of q of x2 y2 passes through the point P. Now we are writing the polar of q of x2 y2, that is s2 is equal to 0. That is the equation x2 plus y2 plus g into x plus x2 plus f into y plus y2 plus c is equal to 0. This polar passes through the point P is x1 y1. Now we have to substitute this point. We are getting here also s12 is equal to 0. This is the equation 3. From 2 and 3 we are writing we are concluding from 2 and 3 the statement is proved. Okay, so this is the note. The polar of P with respect to the circle S is equal to 0 passes through Q is x2 y2. Then the polar of Q passes through the point P. Okay, this is the statement is true. Okay, so see the next the definition conjugate points. What are the conjugate points with respect to the circle? So see the definition. 2 points capital P and capital Q are said to be conjugate points with respect to the circle S is equal to 0 if and only if every polar of the point with respect to the circle S is equal to 0 lies on the other. So see the diagram. This is the circle. Now these are the 2 points. This is the point P and this is the point Q. Now what is here saying? 2 points P and Q are said to be conjugate points with respect to the circle if every polar of the point with respect to the circle lies on the other. That is the Q point is lies on the polar of P. Now we are writing the polar of P with respect to the circle. The polar of P on the polar of P, Q lies on this polar of P. And similar way, the P point is lies on the polar of Q. Now each point lies on the polar of the other. That is the definition. Then these 2 points are said to be conjugate points. These 2 points are said to be conjugate points. In previous note, we are to proving this result. So the polar of P passing through Q, then the polar of Q passing through the point P. So each one lies on the polar of the other. So okay, that is the concept here, the definition. 2 points P and Q are said to be conjugate points with respect to the circle S is equal to 0 if and only if every polar of the point with respect to the circle S is equal to 0 lies on the other. That is, each point lies on the polar of the other point. So that is the definition of the conjugate points with respect to the circle. Okay, see the next note here. This is the note here. The condition that the 2 points P of x1, y1 and Q of x2, y2 are conjugate points with respect to the circle S is equal to 0 is S12 is equal to 0. In earlier, in the last note, we are to observing the polar of P passing through the point Q. Then what is the condition? We are obtaining S12 is equal to 0. So the condition for these 2 points are said to be conjugate points if the condition is S12 is equal to 0. When we have to given any 2 points, then show that these 2 points are conjugate points with respect to the circle. Then what is the condition? S12 is equal to 0. What is S12? What is S12? S12 is the notation x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c. This is the notation of the equation S12. So if S12 is equal to 0, then the given 2 points are conjugate to each other. This is the condition for any 2 points are conjugate points with respect to the circle. Okay, this is the definition and the condition for the conjugate of 2 points with respect to the circle. Okay, next see the definition conjugate lines. What are the conjugate lines with respect to the circle? So see the definition. If 2 lines L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 is equal to 0 are said to be conjugate lines with respect to the circle S is equal to 0 if the pole of each line lies on the other line. Okay, that is the definition of the conjugate lines. In the previous we have discussed the conjugate points. What are the conjugate points? Each point lies on the polar of the other. Here each line pole lies on the other line. Then we say that these 2 lines are conjugate lines with respect to the circle. Okay, so see the note here. So these are the 2 lines. If 2 lines L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 is equal to 0 are conjugate with respect to the circle, x square plus y square is equal to a square is the, here the condition is a square into L1 L2 plus M1 M2 is equal to N1 N2. This is the note I explaining. This is the circle. These are the 2 lines. These are the 2 lines. First line is this is the L1x plus M1y plus N1 is equal to 0. This is another line L2x plus M2y plus N2 is equal to 0. These are the 2 lines. These are the 2 lines. When we say that these 2 lines are conjugate lines. So each line pole lies on the other line. So that is the definition. The pole of first line lies on the second line and second line pole is lies on the first line. Okay, suppose the pole of first line, that is same P, suppose P is the pole of first line lies on the second line and Q is the pole of the second line, then that point lies on the first line. Then we said that these two lines are conjugate lines with respect to the circle. So see the proof for this note. So see the proof. Given circle is here, given circle is x square plus y square is equal to a square. So this is the equation, and given lines are L1x plus M1y plus N1 is equal to 0 is one line, and L2x plus M2y plus N2 is equal to 0. This is the second line. These two are conjugate lines. These two are conjugate lines. Okay, with respect to equation 1. Then we are to proving the condition is a square into L1 L2 plus M1 M2 is equal to N1 N2. That is the condition for these two lines are conjugate lines with respect to the circle x square plus y square is equal to a square. Now we are to assuming that the pole of first line, that is P. Let P of let P be the pole of equation 2 with respect to equation 1. Therefore, what is the pole? We are finding the pole formula. What is the pole formula? Minus a square L1 by N1 minus a square M1 by N1. So this is the formula. We have to find the pole of the line L1x plus M1y plus N1 is equal to 0 with respect to the circle. So this is the formula for finding the pole of first line with respect to the circle. So here these two lines are conjugate lines. Here given these two lines are conjugate lines. Then what is the conjugate lines definition? So the pole of each line lies on the other line. So the pole of first line lies on the other line. So this pole lies on the equation 3, which lies on, since equation 2 and 3 are conjugate lines with respect to the circle equation 1. Therefore P lies on equation 3. P lies on equation 3. Now we have to substitute this point in equation 3. That is L2 into minus a square L1 by N1 plus M2 into, what is y coordinate? Minus a square M1 by N1 plus N2 is equal to 0. So now we are simplifying this one. We are getting here minus a square L1 L2 minus a square L1 L2. Here minus a square M1 M2. Now we are multiplying with N1 on both sides. We are getting here N1 N2 is equal to 0. From that we have to common a square, and moving to right side we are getting a square L1 L2 plus M1 M2 is equal to N1 N2. This is the condition for these two lines are conjugate to each other. So these two lines are conjugate with respect to the circle. Then the condition is a square into L1 L2 plus M1 M2 is equal to N1 N2. So this is the condition for the two lines. Equation 2 and equation 3 are conjugate with respect to the circle equation 1. Okay.